Okay, everyone. Um, Now we're going to start chapter 7 costs. This is the second chapter for midterm two. But yeah, we're just going to jump right in so that we can keep these videos short and sweet. So in this section, we're going to be covering five main topics. The first one is we're going to discuss a little bit about how to measure costs. Economists count both explicit and implicit, and we're going to call these opportunity costs in order to calculate cost. And so opportunity costs would be like if I only have $20 to spend, I'm going to spend it on good one. What am I like missing out if I was going like if what am I missing out that I would get if I was going to spend it on good two? Short run costs to minimize its cost, a firm in the short run, a firm can adjust its variable factors, right? We talked about labor last time, but it cannot adjust its fixed factors. So that was our things like capital. Long run costs to minimize long costs in the long run, a firm can adjust all its inputs because everything is variable. Lower costs in the long run. Long run costs are as low or is lower than short run costs because the firm has more flexibility. Long run technical project progress can occur, and workers and managers can learn from experience. And then we're also going to talk a little bit about cost of producing multiple goods. That if a firm produces several goods simultaneously, the cost of each may depend on quantity of all the goods as it produces. And so this first chapter, we're just going to talk a little bit about short run costs. And this first part is just going to kind of me being a ramble. We're going to get a little bit more into like a little bit into the math towards the end of this video, but yeah, there's only going to be two. This one's going to be just short run costs, and then we're going to talk about long run costs on the next one. So, video one, measuring costs and short run costs. So, one question that we often have is how do we determine efficient production? Um, and we have a little bit of differences when throughout all of these things. So, chapter six, we determined which production processes are technologically efficient, right? This was going to be in chapter six, it was also all about like how to produce. How to produce. Right. Chapter seven is now we're going to be selecting the technologically efficient product process that is also the most economically efficient. So we're going to minimize the cost of producing at a specified amount. This is chapter seven. So this is going to be thinking about like chapter seven. What is the cheapest way to produce? And the next video that we're going to get into is profit maximization. So how to optimally produce. But the last part was technologically efficient. So we're going to be varying differences between labor intensive or capital intensive. This one is going to be economically efficient. So now we're going to talk about costs of production. And the next chapter is going to be how to optimally produce. And chapter eight is um, competitive firms and markets. So we're going to be profit maximizing and we're going to have to compete against other people. And so now we've got a couple other types of costs that we need to consider, right? And so there's going to be these explicit costs. These are going to be out-of-pocket payments such as labor, capital, energy, materials, things that you would see line items for if you're thinking like from a accounting perspective. Then there's these implicit costs. These are foregone opportunities. So if we had to choose between one project and another, and we pick project one, what did we miss out for project two? And then these are also super similar to opportunity costs, but these can also be both explicit and implicit. So it's going to be finding the best alternative use of a resource. And so we're thinking along the lines of like, oh, okay, so there are let's say that we hired skilled laborers, unskilled laborers instead of skilled laborers. Like, yes, they are cheaper, but what are we missing out when it turns into explicit costs? But also very similar to like if we were thinking about project one compared to project two, what was the opportunity cost of not picking project two is a good way to think about opportunity costs. And then there are these things called sunk costs, which are cannot recover. And so it should not matter in production decisions. These are things that we were always going to purchase, or if we did purchase, there's no real way for us to like reap the benefits back from it. There's nothing that we can crawl back. And so these should not matter in production decisions because the money has already been spent and it was going to be spent regardless. And so now let's consider this short run cost. And so we're going to consider this optimization process. And we're going to maximize profit. So this is still going to be profit. These are still going to be revenues, and these are still going to be costs. But now we have revenues and costs as a function of quantity output. And when we have revenues and costs as a function of quantity output, it lets us split up into everything, right? And so we said that revenues beforehand were P times Q, and now our costs, we're going to define a couple of terms. So our cost function here is going to be made up of two things. First, we're going to have F, and capital F is going to be our fixed cost. And our fixed cost is a cost that does not vary with the level of output, right? So if we're thinking about building a company from square one, we are going to need a warehouse to do something, right? So let's think as our warehouse as this large fixed cost. It's going to be a one-time payment. We have to have it, but it's not going to depend on anything that we have to deal with Q. It's just going to always be like we needed a warehouse. Then we have this second component where we have this variable cost um, aspect of our cost function. And so in the short run, some inputs are variable, others are fixed. And for our variable costs, we are going to be things that are going to change with the level of output produces. So if we're thinking in this short run that labor is going to be the one that varies, right? Our capital is going to be fixed. So let's pretend that we were running like a newspaper company. Our capital is going to be the printing press. That is going to be fixed. We have to have the capital, the printing press. We have to have the capital to produce. But our labor, the number of journalists that we're going to hire, are going to change with the level of newspapers that we are going to produce. And so these variable costs are going to be the things that do vary with quantity output. And so our total cost is going to be our fixed costs plus our variable costs. And so again, in our short run, much like we did last time, we're going to hold we're going to hold capital constant and we're going to let labor vary. So now let's think a little bit about differentiating costs, right? So if K naught denotes the amount of initial capital, so this is going to be read as K naught, which just means initial. And if you want to think about this as like T equals 0, so KT, K0, K initial, K naught, you could think about it like that. This is just going to be our initial capital, and R is our rental price per unit. So then our fixed cost is going to be the rental price per unit times the number of units. So this would be number of units, and this would be price per unit. And so our fixed cost is just going to be how much does it cost for each. Now, let's say that L1 is the quantity of labor required to produce an output one, and W is our hourly wage. So then our variable costs to produce quantity one, so this is going to be variable costs to produce Q1 are equal to the wage rate times the amount of labor, right? So this again is wage times labor needed to produce Q1. And so when we throw all of this together, remember our total costs are our fixed costs plus our variable costs. And so it's just going to be R times K naught plus W times L1 in order to produce Q1. And so this would be the total cost of producing Q1. And so graphically, this looks a little weird, right? So when we have our first variable cost curve, right, it's going to be this curve here, right? And so for varying levels of output, right, and we have these Q's here, right? The dollar per hour, right? So these are dollars. And I know that it says it here, but this is dollars and these are our quantity. The cost per unit is highly variable, right? And that's what we see in this graph is that it's not the same. However, we now have our fixed cost here. And so this is essentially saying, okay, here plus 30 is going to take us up 30 units. Plus 30, plus 30, plus 30, plus 30, plus 30. And so graphically, this shows that if our total costs are equal to our fixed cost plus our variable costs, and this is always going to be 30, then the curvature of our variable cost dictates the shape of our total cost. The other way that you can think about fixed costs is that it's simply just kind of an additive term out in front. It's just moving the intercept on the price curve. But yeah, it should be pretty straightforward that way. And so now we're getting into these things called marginal and average costs. So our marginal costs, much like our marginal utility, is the amount by which a firm's cost will change if it produces one more unit of output. So if we were moving from 10 newspapers to 11 newspapers, how much would our costs increase for that last additional unit? Average fixed costs are we're just going to take our fixed costs divided by total output. So it's going to be our fixed costs divided by our total output, right? And these total outputs are going to constantly show up. And then our variable costs are just the same thing, right? And so the things that we really want to look at for these two things is we want to look at our fixed, like we like this average fixed costs, we like this average variable costs. If we wanted to combine them, we would just use the average costs, but we are going to compare average costs and marginal costs lots. So to continue moving forward, these are what all of these costs would look like, right? So if this was our, again, if this was our variable cost curve, and this was our fixed cost curve, and this is now our total cost curve, then we would be able to draw the marginal cost curve. So if we're looking at this, it increases, it decreases, decreases, decreases until it starts to increase, right? So it would cost less and less and less until it starts to skyrocket. Our average fixed cost is going to be the total amount over time, so that's going to be constantly decreasing. Variable cost is going to be constantly decreasing. And so our average total cost is also going to be always decreasing. And so let's think about this AFC curve for a little bit, right? We can also extrapolate to the shape of the AVC and AC. Um, so if we recall, AFC was equal to our fixed costs over Q. Well, if we take the slope over dq, then we're going to get F over Q squared, which, because these are always going to be positive, and this is negative, means that we are going to be less than 0. Similarly, we have average variable costs. And I guess average variable costs may potentially change, right? Because this is also going to depend on Q now. So we're going to get low, D high, minus high, D low, all over low squared. And so this sign largely depends on how these two compare, right? So ultimately, Depending on what way those are going to be leaning, those are going to be more of the important things. And so that also means that our average total cost is just going to be this minus f over q squared plus our q over q squared, right? And so we don't really know what direction this is. This is a fancy way of saying it could be greater than, could be less than, or equal to. Or a fancy way of saying indeterminate or unknown. It's a fancy way of saying we don't know what's really going on. The only one that we can constantly say will have a downward sloping curve always, I mean downward sloping, is the average fixed cost, which is why that's kind of the key focus here. So now let's pivot from the average fixed cost and start talking about um, the shape of the marginal cost curve. And when we're thinking about the marginal cost curve, we are now just going to be deriving. It's gonna boil down a lot. It's going to boil down almost entirely to our variable costs, right? So if we're thinking about this shape, right, we know that this shape depends on the slope. And so our marginal cost curve here is going to be dvq dq plus df dq. Um, or in this instance, right, if this is L, this is going to be just W dL dq plus 0. And so if we recall what our marginal product of labor is, right? So how much does this would be how much does dq, what is dq dl? Then we can say that our marginal costs, and this is going to be some like weird algebra, pseudo algebra calculus, but it's going to be W over the marginal product of labor. So the big conclusion here is that the marginal cost curve moves in the opposite direction as the marginal product of labor curve. That's going to be the big key takeaway here. Um, so now let's think about the shape of the total, like the average total cost curve. So when we're thinking of the shape of the AC, remember we know this, AFC was equal to F over Q. AVC was equal to VC, Q over Q. And if we use this one from before, this was just WL over Q. And we know that APL, recall, so the average product of labor was Q over L. So our AVC can then be rewritten as W. So here, let me just, our AVC can be rewritten as W over the average product of labor. And so then when our AC is our AVC plus our AFC, then we know that our AC has to be U-shaped because our AVC is U-shaped. And so we know that this is U-shaped primarily because we know the AVC moves in the opposite direction of the APL. And the APL, as we recall from beforehand, was hump shaped. So we're going to be U-shaped here. And this pretty much matches what we had up here, right? Our AVC, if we were thinking about this, did start to pick back up. And so we did have a U shape here. And our ATC also had a slight U shape. But our AFC was the only one that declined constantly. So now if we're thinking quantity over average costs, right? We can think about this, right? If we're throwing quantity this way, right? And this is just kind of a zoomed in picture from before. Our AFC is constantly declining. We'll never pick back up. Our AVC, on the other hand, starts to have this slight pick back up right at the end. So this is going to be our U-shaped. And since our ATC is just our AVC plus our AFC, so our variable costs plus our fixed cost, this also has to be U-shaped. And so this is just more of a zoomed in picture of the thing that we just jumped up to. So let's look at an example here, right? Because I think that we've been talking a lot into the abstract. So let's just think about an example here. So first, suppose that a firm's output is given by the production function 3 times capital times labor. If the price of capital is $2 per hour and the wage is $24 per hour, capital use is fixed at 4 units in the short run. Let's graph the ATC, the AVC, the AFC, and the MC. And so when we're thinking about something that looks like this, right? Let's just think kind of in the abstract here. So when we have something here, capital is fixed at 4 units. So our new is 12L, right? Then what is our fixed cost, right? Well, let's think about this. Oh, shoot. Sorry, not that. We want something like this. And L should be $24 for our wage, right? So when we're thinking about this in kind of an abstract way, we've got to figure out a way to come up with a curve that looks super similar to this. Or maybe not average costs, but maybe it'll be more helpful to just draw this in kind of total space first. So if we throw this here and we draw this curve out, and we're going to throw a Q here and a dollars per hour here. We're going to have a lot that plays into this. Sorry, my cursor is going crazy again. Um, and I can't find anything that I want to find. But when we're thinking about this, we need to think one, what our fixed costs are, two, what our variable costs are, and three, what our total costs are. And I might have screwed this. I might have made this incredibly difficult for us by multiplying these together, but I think we'll be okay. Um, so yeah, let's just think about this for a second. We know that our price of capital is $2 per hour, and our capital is fixed or per unit. And our capital is fixed at 4 units. So our fixed cost is going to be fixed at $8. Now, if we're thinking about this, and I think this is where the big thing is here, is that we need to figure out some way to plot. And I think this example that I have here is not the same. So work with me here for a second. Um, I'm trying to pull up my example. Okay. Our fixed costs, I think, should be this 8 across. When we're now thinking about variable costs, we know that at 0, our variable costs have to be 0, right? Um, we're not really given enough information here to fully get all of this, but we should be able to do things in general. So, actually, this drawing this in total space, this might be the reason why I'm freaking out over here. And this might be a good lesson to everybody that when we're thinking about this in total space, it can often get a lot harder than we need it to. So, let's just think about this way. So, if we're thinking our ATC, our AVC, our AFC, and our MC, right? We know that our ATC is equal to AVC plus AFC. Um, and we know that our AVC is just going to be a constant $2 per unit, right? So when we're thinking about this and we're throwing all of these together and we're throwing Q here and dollars per unit of output here, our AVC is going to be fixed at 2. Right? And so our AVC, it's a constant $2, and we know this because um, variable costs increases linearly with our output. Second, our average fixed costs decline as output rises. Since our fixed costs are now spread over more units, and so it would decline like this. And so then our average total costs would just have this rise, and it would be above this. Now, our average marginal costs, right, is going to match the AVC. Um, which is typical in these linear production technologies, right? So this is going to be equal to our marginal costs. Sorry, that one's a little bit clunky. I can walk back through that one if we need to again, when we get back to this. I'm more than happy to provide a better explanation of this. Let's just do another example, right? I think that might be the easiest. This kind of abstract always just kind of gets a little bit in the way of everything, but yeah, let's just look at this cost function. I think it'll be great. I think we'll have a lot better time here. So, considering this, a firm short run cost function is this. First, let's identify the parts of here. So let's find our fixed costs. Actually, you know what? I'm never going to ask you this question. So let's just ignore that one. Our fixed costs are non-varying. And so our fixed costs are going to be this 500 here. Now, let's find our variable costs. And that is going to be the 200q minus 5q squared plus 0.6q cubed. And so our variable costs are going to be the things that vary. And so if we wanted to find our AVC, then we would take our 200q all over our total quantity output, which would be 200 minus 5q. And then if we wanted to find our ATC, total costs, it would be this 200 over q. So now, finding our marginal costs, and again, this is just going to be C prime of q. We get 200 minus 10q plus 1.8q squared, and our fixed costs drop out. So this is our marginal costs. This would be our total costs. This would be our variable costs. If we wanted to find average fixed costs, we could do 500 over q. Let's do another example, right? But this time let's think a little bit differently. So first, what happens if find the average cost when q is equal to 16? Well, we know our average total cost is just C over Q. And so our cost at 16 units over Q, which would be 16, is going to be times 16 cubed minus 4 times 16 squared plus 75 times 16 plus 100. Divide that by 16. It's going to be like 81.25. I got this to be 1300. What about finding the marginal cost when Q is equal to 16? Well, in order to find the marginal cost, we need to take C prime, which would be 0.75 Q squared minus 8Q plus 75. And at 16, $139. Find the output level when average variable cost is equal to marginal cost. So if we wanted to say AVC, remember we would take this 0.25Q cubed minus 4Q squared plus 75Q all over Q. And this would be 0.25Q squared minus 4Q plus 75. So 3 when is AVC equal to MC. So now we're going to take this and set it equal to this. The 75s are going to fall out. So we're going to be left with 0.75 q squared minus 4q should equal 0.75 q squared minus 8q. And so these are only equal when output is equal to 0. Right? And so if we wanted to think about these in a curve, all right, so let's take Q over here. Our average marginal costs start at 75 and they will look like this. And our average variable costs, oops, sorry guys, will look like this. And our average total costs would be something very similar. It might be above because we're going to add our fixed costs. Something that looks like that. And this would be our ATC, this would be our AVC, this would be our MC. And remember, our total fixed costs are going to decline like this. So this would be something like our AFC. So it's an interesting way that all of these work together, and it's an interesting way that they all kind of connect, but for the most part, they all have similar shapes and they should be reflective as such. So a summary of short run costs are just costs that can't be adjusted. They're fixed. They're cost of inputs and can be adjusted variably. Shapes of the short run cost curves, the variable curves, the marginal cost curve, and the average cost curve are all determined by our production function. When a variable input, when we here have labor, has diminishing marginal returns, cost and variable cost and marginal cost become steeper as output increases. And so the average cost, the average variable cost, and the average marginal cost curves rise with output. And this all happens when the marginal product of labor declines. Um, when the marginal cost curve is below the average variable cost and the average costs, it's going to pull both down. So if we come back up here, we saw, so this is our average costs here, and this was our average variable costs. When our average marginal cost was below both of them, notice that they don't start picking up. Like they don't start slightly turning positive until the marginal cost curve passes them, right? When the marginal cost curve was above it, then they both, well, here you notice that it starts pulling it up immediately, and then here they also start pulling it up immediately. And so the marginal cost curve is going to intersect both of these points at their minimum points, right? And so when the marginal cost is equal to the average variable cost, it's when the average variable costs are minimized. When the marginal cost curve intersects the average total cost, it's when the average total cost is completely minimized. Um, and I think those are just kind of the big points. Those are all summarized down here. Um, so yeah, this would just be the minimum point, right? So at their minimum points, when they're both, it's going to be pulling so above, up, below, down. But again, if you want to just plot those, you should be fine. Sorry, my plotting when I'm live just kind of sucks. Um, but for the most part, I can go back through and I can post an announcement to help fix that one that we screwed up on. But I'm gonna honestly just fully say that like we're not really going to be doing that question very much. And it definitely won't be on the exam. So you don't really have to worry about that too much. If that's the only part that confused you, that's perfectly fine. So now we're just finished up short run costs and we're going to be jumping into long run costs. So thanks for sticking with me. Sorry about that screw up. We'll figure it out. Thanks.